Hello and welcome back for another tutorial, and today I want to show you how you can create the surfaces that you can use maybe for your practice. And here I have this plugin which I downloaded from Autodesk. It's a free plugin, so sometimes when you go to the Autodesk website you can find some of these softwares you can use to make your work easier. For example, if you don't have survey points, you can use the random surface generator, so it will usually create random surfaces. So let us maybe create one surface here. So I want to use just go here, click, and after clicking, now it is showing you click the start point. So I just come here, I pick, but before I pick, maybe I want to show the number of points I'm expecting for my project. So I can just come here and maybe say 1000 points, which is okay. Then the other things like the horizontal scale, the vertical scale, and others you can just maybe let's just go with random, or put a number like 4, or let's try 7. And also now we can just come here and click the start point and also the end point like this, and now it has created a surface. So let's see what we have here, like this, and now you have a surface which is just random. And this surface you can just go to the properties, and maybe if you want you can also change the name of the surface, maybe call it the OGL surface like that, apply. Okay, so anytime I come to the surface it has this name. So the next thing I want us is to, for this reason, I wanted us to create a simple road which can form some discussion for today on how you can create maybe a small road, that maybe a nested road, or with not much controls, but just go to the sub-assembly composer, and maybe let's suppose a small cross section here. Maybe let's say this is the center line like this, and then from the center line we just draw only one side like that, and maybe like that. So this is the carriageway, and maybe we can just offset this one by, let's say 0.25 or 0.05 like that. Is it too small? Let's see, because we are dealing in meters, so 0.05. Yes, and then maybe we have another area which is like 0.15 like that. And maybe this one we can just come here and say a carriage width of, for example, 3 meters like that, and then you can trim the rest. And also after that, the rest we can just join this one that. And then you can also have a shoulder here, maybe it is just the same slope, or not necessarily the same slope, maybe it can be different. And then we have the slope that joins to the edge of the road. But also you can also have this case when the road is above the OGL, like this. But you can also have another case where now when the road is below the OGL, for example like this. Maybe if you have a road which is like this, and then maybe you can just come here and then like this. Okay, so this one will be the continuation of the surface, like that. So when you are above the ground, original ground, this is what you have. When you are below the ground, because this can be, if we just continue like this, maybe let's do this one to be like dotted like that. So it means this is the space that you're going to, this is the area of cut, and in this case this is the area of fill. So we can go ahead and do the shading. Let's do like this, maybe do the same here. So this one you can just come here and change to something different, maybe like this, and also 0.25 I think, or 0.15, and also this one becomes like the same, 0.15. So this is the area of cut, this is the area when we are doing a fill. So in this case now we can just bring this one a bit close to our surface, the one that we have created, so that you can be able to make some reference. So from there we can now, let's just make a random road alignment. So let's just come here, maybe let's assume our road goes like this, like that, like that. So this is our road, which has a length of 5.829 kilometers. So from there you go ahead and maybe we can have we can create an alignment here. So let's see where how do we create an alignment. So you just come here and then you can create from objects, and this is the object, the polyline that I'm going to use. Then just click and you can see it is showing the direction of the, if this is our zeros and this is the end. So we just accept, and now you can call this, give this one a name. For example, we can call this one round centering, proposed round centering, like that. And maybe we can also have some major and minor. These are the labels that you're going to use, or you can just have all the labels, and we can and the curves, because of course our road is not going to have these sharp corners. So if we agree that we want to have a default radius of the curves between the straight points, the straight tangents, to be the arcs of 200 meters radius. So we can just go with this one. Of course, you can change if you find that you want to change, and then maybe we can also erase this red polyline if we accept to have this one with a tick. So we go ahead and click OK. Now let's see what we have. Now this is our alignment, and this is the way it looks like. So from there, now let us create a profile that we are going to use to base our drawing, so to base our design on this one. So we can go ahead and create a profile. So let's create a profile from surface like this, and we are going to select this surface, the OGL surface that we have created, and then we go ahead like that, and we go ahead, and then we can create our profile. But then when you come to this one, maybe sometimes you want to also show between two, for example the OGL and the design, how much is shaded as per the cut area or the fill areas. So for now, let's not use it, and then go ahead and create like that. So now we have our profile here, and this is what we have. And maybe we are not having a lot of a good display. Maybe sometimes we just come here and let's see what we have. If we do like this, maybe let's try 1000. I think it's going to 1250, or let's just try 1000, and then after that we can also change this one. We go to the profile view properties, and maybe I don't want to show this one, but I can also, and just I have one created here. So let's see what we have here. Let's see if we have the and put this one to 0, and we have our elevation. It's showing us the elevations here, so we can also add another one that is showing us the stations. So let's see, and okay, 0 apply. So now we have our, this is the profile of the OGL, or the profile that is as per this surface. So for us to be able to create a proposed road, we can go ahead and create we can create as a new proposed profile. So what you do, we can just come here, and maybe sometimes I find it there are two ways you can do it. Maybe you can just use this method I'm going to suggest here, like that. Maybe so for you to create the profile, you can just come to the profiles here, and then you create a profile by layout, and this is the profile that's we are going to the profile view, and then we want to call it the design profile. Like that. Then we go ahead. Now we get these design profile window here, and now you want to start. Maybe we can just don't know why it is displaying like this. Let's go again, the layout. Call it design profile. Yes, like this. Now we can have a way of just an easy way of creating the profile. So we can just come here and do some settings. So these are the values you can change. Maybe sometimes you can also use the circular, and you can use the, for example, a default radius of say 150, and then okay. Now when you come here, now you can draw tangents with curves. So you just start from the start here. Maybe you just try to be, sometimes it's good to just be as close to the surface as possible. So as you can see, as I continue to drag press the points, you can see the curves are automatically appearing like that. So what will happen is that it will give you a smooth curve, and you can just come here like that. And maybe some places you can just like that. And there's no need of worrying, because if you don't find it appealing, you can always change on the settings for the profile. For this one, I'm not using any code. I just want to give you an illustration of what can be the way to go about it. So doesn't matter for now, and I can just go ahead here, and then maybe, I don't know, if I just click here like this, and then maybe the last part like that. So as you can see, my curves and my change points are now governed by these curves here. So this is my proposed road, and as you can see, if I want, I can just change like that, maybe to get smoother curves and all that. Sometimes if I don't want, I can just remove this one, for example, and then I don't have it. Maybe do I need to, maybe I can have it here, but now I need to add a curve, so I just stick with what we had like that. So I don't want to spend a lot of time here because I want to show you how you can create this road on the subassembly composer. So you go to the subassembly composer, so you go to the subassembly composer, and now you need to create the simple road. So the first thing is to get the point, and that is usually the first point, and the next thing is maybe we can add another point here. Now this it has a link, and this link here, we want to have this point, the second point, to be at an angle delta x, let's see, angle and delta, no, slope and delta x, I think. Yes, slope and delta x. So what I like to do is to come here and create a parameter. So the first parameter is the side. Of course, this will be the right side. So I want to do a crossfall. Maybe you can call it a road crossfall, like that. And I want it to be, I don't know if I put in green. Yes, I can put in green, for example 2.5, and now in this case the angle will be, the slope will be, just copy this one and I just paste it here like that. Now so the distance, you remember here, is we indicated a distance of, I think, 2.5 or 3 meters. But now what you notice is that we don't necessarily need to have it at 3 meters, so we need it to be able to change anytime we have a new design. So what we can do is we distance here of the wind, so we can call it road wind. That is on one side, so we can just give it like 3 meters. So in this case we just copy like that. So yes, so if we change this one to 2.5 for example, we can already see now it is adjusting. So for example, let's go back to 3 meters. But now this also becomes cumbersome when you have a very long road like this one. So for example, you might like to have a polyline which you want to be controlling the road wind. So in that case we need to have an offset parameter. So we go to the target parameter and then we create an offset parameter, and then we can call it road offset, like that. And now we can adjust it like that. So if we come here, we can now have an override of this delta x. So we can just come here and give now this one. So this one is the one that is now controlling the wind of the road. So what we want now to do is we need now to come back here and dictate how much we want to have as this distance here. So this one, for example, this is I think it should be 0.05. so in this case we can have a point here below P1. So we go ahead, have a point here, and this point we want it to be below the point 1, so it will be delta x, delta y. In this case delta y will be 0. No, delta x will be 0, but delta y will be the wearing course thickness. So we just come here and type wearing course thickness, like that. So in this case maybe 0.05, and this one we need to change now the delta y to be the wearing course thickness. So we just copy and then we put minus the wearing course thickness. So let's see, but now it is not from P2, it is from P1, like that. So you can see we now have this link, and then this P3 is at the wearing course thickness. So we can also do the same at the edge, but sometimes we might not want to just have this one uniform. Maybe we can have this one thicker or maybe smaller. So we can also have maybe you can change this one. We have this one is maybe instead of calling it the wearing course thickness, we can call it crown wearing course thickness, and now we have to update this one, because now we have changed the name like that, and then we paste here. Remember, it is negative, so like that. Now we do the same again. We create another parameter and call it eng wearing course thickness, like that. And then maybe we just use the same value, so we can just like this. And now we add another point, but this time it is from P2, and we just copy this one, copy, and then it should be negative, like that. Okay, so the next thing, we need to cross this gap with a link only. So we just come here, so we need to connect between P3 and P4. So just come here, and then now we have a crossed space and the crossed shape. So for that, now what we need to do is to include a space here, a shape here, which will now give us the material when we are calculating the volumes or the road components. So we just come, pick the shape like that, and now we want to put this shape inside of here. So we just click here, and then we tap to the inside. Now it is there, as you can see. Maybe we can call this one the wearing course, like that. But now we need to add the same here, wearing course. Now we just we need to change to string, because that is a code. So we put wearing course, like that. So after that, we need to repeat the same. So it is just the same thing here. So we just come point, and now this time it is from P3, and now we need to get maybe we can call it the base course, base thickness, like that. And we maybe can put it 0.15, I think, and then we need to copy and paste. So as you can see, now it is this distance is the base thickness. Maybe we can add a link like that. So we also have a link that is connecting. So we can also do the same here below P4. We come pick the point, and maybe we can also do the way we did here, but because this is just for practice, we can don't need to keep on, because of time. We can just copy this one, and then we want it from P4. So P4, and then it is delta x, delta y, and y is minus the base thickness, like that. So what is remaining is just for us to connect P5 and P6. So we click link here, and that link should be between P5 and P6. So what else is remaining is the shape. So we pick the shape like this, and then here, and then we just, now we can give this code and maybe call this one the base. So we just come here, type base, and we want it to be string, so call it base course. Now we have already now created the main part of the garage view, but now we also need to include the our, whether we are in cut or whether we are in fill. So we need to examine what we have here, and if we go up to this point, we can decide to have our point from here to here within the main structure, or we can just pick everything and then use it in both cases. But I think we can just complete this one, because either way this part and also this part are similar. So whether you are in cut or whether you are in fill, it doesn't make a difference. So you can just come here and maybe add the shoulder now, and maybe we can add the shoulder width, like that, and now the shoulder width maybe can give like 1 meter, like that, and we need to drag a point like that, and this point will be from where? From P2, because it is from this point, but now it is slope and delta x, like that. Now we also need to have another parameter. We can call it shoulder slope, so that we can be able to change if we want. Maybe not necessary that we have this slope and the slope of the shoulder to be the same. Sometimes we can change. So let's put this one in the grid. Now we can put like 3% or even 2%, like that. So copy this one, and now we want negative, like that. And what is the shoulder width? Shoulder width now here we have, and we can just override the x. So first of all, we change the delta x to become shoulder width, like that. And where do we have it? Let's see. Yes, like here, like the way we are having. But now I think this is too big, so we can just call it maybe 0.5. But it doesn't matter, because anytime you want, you can always change. And that is one thing you can be able to control. Of course, you can even use the override, but I don't want to use it for now. So let's also add a link. No, we just pick this one here, and we can just activate the link, like that. So supposing we don't want this 2%, for example, we can let's say like 2.5%, and you can see now this is accepting the change. So I think the next thing we need to do is to now be able to now activate whenever we are in fill, or whenever we are in cut. So for us to do that, first of all, we need to have the surface. So we can create another parameter. We can call it the OGL, that, and it is the surface. So now this is the surface, for example. So let us, first of all, we need to have a decision. So decision allows us to be able to decide where we want our links to go and our points to go. But before we bring in the decision, so not so fast, so we can just have an auxiliary point. So let's bring an auxiliary point here, and this auxiliary point will be stuck on the ground. So we can just put delta x on surface, and our surface is the OGL, like that. So maybe we can also get rid of the link, like that. And now we want to now bring in the decision here. Now the decision, we are going to create a condition. Let's push this one here, like that. For example, I think let's put this one somewhere like this, so that we create more space. Forgive my retro space that I'm using. To make the work a bit organized. So is anything wrong? Yes, because we have not allocated anything to our decision. So what we can do is we need to create an expression, and that expression, for example, when we are in let's say we are in fill, we want to say that P7 multiply dot y is greater than AP1 dot y. So what does that mean? It means we have a case where P7 is above AP1 according to this one. So what do we need to do? What we need to do in this case, we are in fill. So if this is true, we need to have a point, okay, and that point connects to the true case, like this. Sorry, like this. And this point will need to be slope to surface. And what is the surface? The surface is the OGL. But you also need to now, where does it originate from? It originates from P7, like that. Now we need to come to the parameter, and maybe we can create this final slope, and maybe we can call it the embankment slope. Maybe in this case let's use a slope. Let's say 1 against 1, like that. So just copy, and then here we paste, like that. So So we also need to activate the link like that. So it means now we are in a case of fail. Supposing when we are in a case of cut, then this one does not show because now we have overridden this case. So how do we deal with that? How we deal with that is we can now create another link that joins to the surface in the case that we are in a position of cut. So we need to drag a point, but now this time from the force side like that. Now that point must be maybe from, we can work with the slope and delta. We can work with slope and delta x like that. But now we need also to add something else that will give us our slope here, because now we are the one to construct our slope based on what the design is allowing us to do. So in this case we can add another parameter that gives the embankment slope wind, and so we can give it like 1 meter. And in this case now we need to maybe copy this one from P7, I think, from P7, and the slope is, no, the wind is the embankment slope wind. And also now how much is the slope? The slope we can just work with the same, so we can call it we can copy the embankment slope, copy like that. So now this is what we have designed from the design, or what we have been given by the engineer. So sometimes if we don't want the embankment slope width of 1, we can change, or the slope we can also change. But remember that if you change this slope, it will also change whenever we also in when we also in fill. So that is one part of the construction. So let us, yes, like that. Maybe we can push this one here. Is it? Yes, like that. Now the next thing, we add another point here, and we can call this one the ditch slope, the ditch wind, sorry, ditch wind. We can use this one as a ditch wind, and maybe we can call it 0.5. So in this case we are coming from P9, and then we use delta x, delta y, so the x will be the ditch wind. So we copy this one here and we paste like that. Now we have our ditch. Now the final thing is the slope here that attaches to our surface, which is in this case above the road. So what we need to do is we just come here, and now we add another point, okay, and this one will be slope to surface like that. And where is the surface? The OGL. but now we also need to change the slope because this time it is positive. So what you can do is we can create call it the back slope. Like that, and it's the slope. You can change to anything, you can even put 1 to 1. So we just come here, we copy, and now in this case we paste here like that. So if you now move the OGL, it is working like this, you see. So, and also maybe you can change the width of this road according to our layout on the surface. So I think for this one maybe we can stop at this point, and next time we look at we complete the rest, because my video will become very long and maybe you might not be able to practice all these in one go. So thank you very much for your time, and continue subscribing to my channel, and until next time, goodbye.